15 billion miles from Earth, a machine older than the Internet, older than most of the engineers now fighting to keep it alive, did something nobody at NASA could explain. It stopped speaking. Then, without warning, it began sending back signals that made no sense. Not silence, not static, but a repeating pattern that no computer on Earth could decode. A spacecraft that had operated almost flawlessly for nearly half a century suddenly appeared to be transmitting the impossible. And when engineers finally uncovered what was really happening in the endless darkness between the stars, the answer changed everything we thought we knew about how long humanity's greatest explorer could survive. This is that story. But before we dive in, if you enjoy mysteries of space, forgotten history, and incredible true discoveries explained through cinematic documentaries, make sure to subscribe and turn on notifications. It helps the channel tremendously, and you'll never miss our next journey into the unknown. Now, let's begin. On the night of November 14th, 2023, deep inside NASA's Jet Propulsion Laboratory in California, a routine transmission arrived from the most distant object humanity has ever built. Voyager 1 had been calling home every single day for 46 years. Its messages were incredibly faint, a whisper of radio energy weaker than a refrigerator light bulb by the time it crossed the unimaginable gulf of space. But they always arrived, and they always made sense. Except this time, they didn't. The signal itself was perfect. The carrier wave was locked. The spacecraft was unquestionably alive. But the data hidden inside that signal was complete gibberish. An endless stream of ones and zeros that meant absolutely nothing. Think about that for a moment. Voyager wasn't dead. It was talking. It just wasn't saying anything anyone could understand. Engineers compared it to hearing a heartbeat over a phone line. But no voice. Somewhere in the freezing darkness of interstellar space, something had scrambled the mind of humanity's farthest machine, and nobody on Earth knew why. What happened next would become one of the most extraordinary deep space rescue missions ever attempted. Voyager 1 isn't powered by cutting-edge technology. In fact, its computers belong in a museum. Yet somehow, they're still operating billions of miles from Earth. The spacecraft relies on just 3 onboard computers sharing only 68 kilobytes of memory. Their processors run at a mere 250 kilohertz, and new commands reach Voyager at an astonishingly slow speed of only 16 bits per second. Compared to the device in your pocket, the technology is unimaginably primitive. Time created another problem. The engineers who originally built Voyager had retired decades earlier. Many were no longer alive. The new generation at NASA's Jet Propulsion Laboratory found themselves studying faded paper manuals, handwritten diagrams, and engineering notes from the 1970s just to understand how the spacecraft systems actually worked. Days turned into weeks. Weeks became months. Nothing they tried solved the problem. A mission that had survived the intense radiation around Jupiter, safely navigated Saturn, and crossed the very edge of our solar system now seemed to be fading away, not with a dramatic explosion, but with meaningless streams of digital noise. Quietly, some experts began accepting that the mission might finally be over. After all, no one had ever repaired a spacecraft from such an unimaginable distance. There wasn't even a playbook for attempting it. But the Voyager team refused to give up. In March 2024, they tried something remarkably creative. Engineers transmitted what they called a poke, a carefully designed command intended to persuade Voyager to send back a complete snapshot of its computer memory. Nearly 2 days later, the response finally arrived. Hidden inside that enormous stream of data was a tiny clue that changed everything. The mystery wasn't caused by some unknown force in deep space. It came down to hardware. A single memory chip inside Voyager's flight data subsystem, the computer responsible for organizing scientific and engineering information before transmitting it to Earth, had failed. About 3% of its memory had become permanently corrupted. Imagine trying to hold a conversation after losing part of your memory. That was exactly what Voyager was experiencing. The challenge facing NASA was almost impossible. No astronaut could travel there. No replacement parts could be delivered. Even something as simple as restarting the computer carried enormous risk. One incorrect command could permanently silence humanity's most distant spacecraft. So the engineers attempted something never done before. Instead of repairing the broken hardware, they rewrote the spacecraft's software from Earth. They carefully separated the damaged code into smaller sections and relocated each one into healthy areas of memory that had never been intended for those functions. Every address, every reference, every instruction had to be rewritten by hand so the entire system would continue operating as if nothing had changed. Then came the hardest part. Waiting. In April 2024, the repaired software was transmitted across more than 15 billion miles of space. Nearly 2 full days later, the answer finally returned. For the first time in 5 months, Voyager sent back readable engineering data. Inside NASA's Jet Propulsion Laboratory, relief quickly turned into celebration. The impossible had worked. By June 2024, all 4 of Voyager 1's active scientific instruments were operating again, collecting data from a region of space that no other human-made object has ever explored. Think about how extraordinary that really is. A spacecraft launched while Elvis Presley was still alive had just received a software update from across interstellar space. Most news reports described the event as little more than a technical glitch that engineers managed to fix. But those closest to the mission understood what had truly happened. Humanity had completed the most distant repair ever attempted. And remarkably, that wasn't even the most incredible part of the story. Because the real mystery isn't the broken computer. The real mystery is the data Voyager continues to send home. Again and again, its discoveries have challenged predictions that scientists once believed were solid. In other words, humanity's most distant explorer keeps revealing that our understanding of deep space is still incomplete. To understand why, we first need to understand where Voyager actually is. In August 2012, Voyager 1 crossed one of the most important boundaries in the solar system, the heliopause. This invisible frontier marks the outer edge of the heliosphere, the enormous magnetic bubble created by the continuous flow of charged particles streaming outward from our Sun. Beyond that boundary begins true interstellar space, a vast environment filled with thin plasma, drifting dust, and magnetic fields stretching between the stars. Only 2 spacecraft have ever reached this region, Voyager 1, and its twin, Voyager 2. Every measurement they collect is completely unique. No spacecraft before them had ever sampled this environment, and it may be decades before another mission reaches the same frontier. That alone makes every bit of information priceless. But what surprised scientists wasn't simply where Voyager had gone. It was what Voyager found after it got there. Researchers expected that once the spacecraft crossed the heliopause, the direction of the magnetic field would shift dramatically. On one side would be the Sun's magnetic influence. On the other would be the magnetic field of our galaxy. The two should have pointed in noticeably different directions. Instead, they were almost perfectly aligned. Rather than colliding sharply, the magnetic fields appeared to flow alongside one another, as though the boundary surrounding our solar system was gently bending the galaxy's magnetic field around itself, almost like water smoothly flowing around the bow of a ship. It wasn't what the models predicted, and it was only the beginning of Voyager's surprises. Then, in 2020, long after Voyager 1 had crossed the heliopause, it recorded something scientists weren't expecting. The spacecraft detected a noticeable increase in the strength of the surrounding magnetic field. It may sound like a small detail, but its implications were enormous. Researchers realized this could mean the Sun's magnetic activity occasionally pushes the heliopause farther outward. In other words, the boundary of our solar system may not be a rigid, unmoving shell at all. Instead, it could behave more like a living membrane, expanding and contracting over time. It's almost as if our solar system has a pulse, and Voyager 1 became the first object ever to sense that pulse from beyond its edge. Then came another surprise. Not something we could see, but something we could hear. In late 2018, NASA announced that Voyager 1 had detected a steady vibration traveling through the ionized gas between the stars. Later analysis confirmed it wasn't a one-time event, but a constant, faint plasma hum filling interstellar space. For decades, scientists believed the space between stars was mostly quiet, interrupted only when powerful eruptions from the Sun disturbed it. Voyager revealed something very different. Its plasma wave instrument kept detecting a soft, continuous vibration, as though the fabric of interstellar space itself was gently humming. The silence everyone expected simply wasn't there. The emptiness between the stars isn't truly silent. It has its own quiet voice. And the only instrument listening to that distant melody belongs to a spacecraft using less electrical power than a typical microwave oven. Voyager's particle detectors uncovered another mystery. Its low-energy charged particles experiment, known as LECP, began measuring pressure fronts beyond the heliosphere. These weren't visible storms. They were invisible shock waves moving through interstellar space, drifting like weather systems across an ocean humanity had never explored. Each new observation pointed toward the same conclusion. The region beyond our solar system isn't empty or calm, it's dynamic, it's organized, and it's far more complicated than scientists once imagined. Perhaps the most astonishing part is that we're learning all of this from a spacecraft that's slowly running out of time. Because there's one uncomfortable reality that every engineer working on Voyager understands. Its power supply is fading, and there's no way to stop it. Unlike satellites orbiting Earth, Voyager can't rely on solar panels. Sunlight that far from the Sun is simply too weak. Instead, the spacecraft depends on radioisotope thermoelectric generators, nuclear power systems that convert the heat released by decaying plutonium-238 into electricity. When Voyager launched in 1977, those generators produced about 470 watts of power. Today, they generate only around 250 watts, and every year that number drops by another 4 watts, just 4 watts, a surprisingly small amount. Yet those few watts separate a functioning spacecraft from a silent piece of metal, drifting forever through interstellar space. Operating in temperatures close to minus 270 degrees Celsius makes every decision even more difficult. Turning off a heater saves precious electricity, but it also increases the risk that critical components could freeze. Some of those components control the spacecraft's ability to keep its antenna pointed toward Earth. Lose that capability, and communication ends forever. Then another crisis arrived. On February 27, 2026, during a routine roll maneuver used to calibrate Voyager's magnetometer, engineers noticed an unexpected drop in available power. It wasn't part of the plan, and it immediately raised alarm bells. If power continued falling, Voyager's onboard undervoltage protection system could activate automatically. That emergency software was designed decades ago to protect the spacecraft by shutting down systems on its own whenever electricity became too limited. Think about what that means. A spacecraft built in the 1970s, sitting more than 24 light hours away, could suddenly begin deciding for itself which systems deserved to stay alive and which would be sacrificed. Once that process started, engineers warned that recovery would be slow, uncertain, and incredibly risky. With hardware this old, there are no guarantees, so NASA acted before the spacecraft was forced to. On April 17, 2026, engineers at the Jet Propulsion Laboratory sent a command that no one wanted to send. Voyager 1 was instructed to switch off its low-energy charged particles instrument. That experiment had operated almost continuously since the spacecraft left Earth in 1977. For nearly 49 years, it had faithfully measured the energetic particles flowing through space. It helped scientists understand the invisible pressure waves beyond our solar system. It played a key role in confirming Voyager's journey into interstellar space. And now, the very people who had spent decades protecting it were forced to silence it. Even that final command wasn't immediate. It traveled through space for roughly 23 hours before reaching Voyager. Then the spacecraft needed another 3 hours to complete the shutdown sequence. Mission manager Karim Butterbaugh summarized the decision with remarkable honesty. No one wanted to lose a science instrument, but there simply wasn't a better choice. Yet one detail about LECP borders on unbelievable. Hidden inside the instrument is a tiny stepper motor that slowly rotates the sensor so it can observe particles arriving from every direction. Before launch, engineers expected that motor to survive around 250,000 individual steps. That was considered more than enough for the original 4-year mission. Instead, it kept turning. Year after year. Decade after decade. By 2026, it had completed more than 8.5 million steps, over 30 times beyond its expected lifetime. Even after its heater was switched off and its operating temperature dropped to approximately -62 degrees Celsius, it continued working. Its creator, Stamatios Krimigas, is still alive to witness the machine exceed every expectation. Engineering isn't supposed to work like that, but Voyager has spent nearly half a century rewriting the rules. And despite what many headlines suggested, shutting down LECP was never intended to be the spacecraft's final chapter. It was a strategy to buy more time, roughly another year. Enough time to attempt something even more daring. Right now, in 2026, NASA engineers are preparing one of the most ambitious power management upgrades ever attempted on a spacecraft operating in deep space. Inside the mission, the effort has earned a memorable nickname: the Big Bang. The concept is surprisingly simple. Replace groups of aging power devices together, retire unnecessary equipment, introduce lower power alternatives where possible, and carefully redistribute the spacecraft's remaining electricity. The goal is straightforward: keep Voyager alive, keep it warm, and keep the science flowing. But achieving that goal is anything but simple. Engineers are effectively redesigning the electrical system of a nuclear-powered spacecraft that's been flying for nearly 50 years, and they're doing it billions of miles from Earth. Every command requires almost 2 days before anyone knows whether it succeeded. If everything works as planned, NASA believes the upgrade could postpone additional science instrument shutdowns by at least another year. Because the risks are so high, The procedure is being tested first on Voyager 2. That spacecraft still has slightly more available power and sits a little closer to Earth, making it the safer choice for the first trial. If those tests succeed, engineers hope to perform the same upgrade on Voyager 1 later in the year. And here's the part almost nobody expected. If the Big Bang performs exactly as planned, Voyager 1's LECP instrument, the one switched off in April, could actually return to service. An experiment that seemed lost might once again begin collecting data from interstellar space. The scientists involved genuinely hope that happens. At the same time, they know the reality. The engineering team has repeatedly found extraordinary ways to stretch Voyager's remaining power. Again and again, they've accomplished what once seemed impossible. But eventually, there will be nothing left to stretch. And all of this, the computer failure, the record-breaking repair, the growing power shortage, and NASA's boldest engineering gamble, is unfolding just as Voyager 1 approaches a milestone unlike any humanity has ever witnessed. Because this November, the spacecraft will cross a distance no human-made object has ever reached before. On November 18, 2026, at exactly 2:16:07 a.m. Pacific Time, Voyager 1 will reach an extraordinary milestone. At that moment, it will be approximately 16.09 billion miles from Earth, the exact distance that light travels in 24 hours. For the first time in history, a human-made object will be one full light day away from home. Pause and think about that. Nothing in the universe travels faster than light. In a single second, light can circle Earth more than 7 times. It reaches the Moon in just over 1 second, and the Sun in about 8 minutes. Yet by late 2026, even light, the ultimate speed limit of the universe, will require an entire day to catch up with the spacecraft built using technology from the 1970s. Voyager has traveled so far that everyday communication has become almost surreal. Project manager Suzanne Dodd once explained it this way: if she sends Voyager a simple "Good morning" at 8 o'clock Monday morning, the earliest reply won't arrive until roughly 8 o'clock Wednesday. Every exchange with humanity's most distant spacecraft now spans at least 2 days. At this point, the engineers aren't really having conversations anymore. They're sending messages into interstellar darkness and patiently waiting for letters to return. As astonishing as that distance sounds, the universe quickly reminds us how small it really is. When Voyager reaches the 1 light day mark, it will be about 5.6 times farther away than Neptune. That sounds enormous, until you compare it with the distance to the nearest star beyond our Sun. After nearly 48 years of non-stop travel at roughly 38,000 miles per hour, Voyager will have completed only 0.0027% of the journey to Proxima Centauri. Read that number again, less than 0.003%, nearly half a century of flight. And humanity's fastest traveler has barely begun crossing the distance to our closest stellar neighbor. That's how unimaginably vast space really is. Our greatest explorer has sailed only a tiny fraction across an ocean that has no visible shore. And surprisingly, Voyager hasn't completely left home yet. Not in the way most people imagine. Beyond the heliopause lies the Oort cloud, an immense shell of icy objects still held by the Sun's gravity. Voyager won't even reach its inner boundary for roughly another 300 years. Passing all the way through it will take close to 30,000 more years. By then, every civilization alive today, every nation, every language, every achievement, every love story will exist only as distant history. So, where does the mission go from here? The honest answer is both inspiring and heartbreaking. Today, only 2 scientific instruments remain active aboard Voyager 1. One measures magnetic fields. The other, the plasma wave subsystem, continues listening to that mysterious hum echoing through interstellar space. Current estimates suggest the spacecraft can continue returning valuable science into the early 2030s.